In these slides, we want to discuss what happens with the potential for a conductor in equilibrium. So first, let's review a few properties of conductors in equilibrium. Number one, the extra charge resides on the surface. If you put extra charge on a conductor, in this case you're taking negative charges out, then the positive charge remaining has to be at the surface. Okay, second thing is the electric field is zero inside the conductor. If the electric field was not zero, then there will be charges moving, then you won't be in equilibrium. So the electric field has to be zero in equilibrium. Then the last thing is that the electric field just outside the conductor is perpendicular to the surface. We're talking about just outside, not going too far away. Inside it's zero, and just outside it's perpendicular to the surface. Okay, if you want to get the potential difference between points 2 and 1, which are located at the surface, how would you get that? Think about it. Well, if you apply the rule for the potential difference between 2 points, the general rule, and you choose a path on the surface, you notice that the elements of length are always perpendicular to the electric field, because the electric field is perpendicular to the surface. So that means that this integration is zero, and that means there's no difference in potential between points 1 and 2. So that means that the surface of a conductor is an equipotential surface. If you get the potential at this point, or you get the potential at this point, or you get the potential at this point, or at this point, it's all the same value. Okay, what about if I take a point inside the conductor, point 3? What is the potential difference then between points 1 and 3? Well, if we do the same thing, we make a path going from 1 to 3. In this case, the path exists inside the conductor. Since the electric field is zero everywhere inside the conductor, then E is zero, then the potential difference is zero. That means V3 minus V1 is zero. That means that the potential actually everywhere, inside and on the surface, everywhere the potential is the same value. If the potential here at this point is 100 volts, then the potential here is 100 volts, then the potential here on the surface is 100 volts. Everywhere it's the same value.